Good morning, welcome back to Pythagoras. Actually, this Pythagoras is a group of scientists. It's not a single person who found all these theorems. There are so many theorems by with this same name, Pythagoras theorems. But actually, it is a group of mathematicians, and their head is Pythagoras, and the team is known as Pythagoreans. So all the yes, yes, Karthik, his photo is there, and all the theorems proven by that term during that year, and those theorems came under the name of Pythagoras. So all other scientists' name won't come out, and since he is the leading person, dominating person, all the theorems came under his name, Pythagoras. Okay, so others' name we not came out. We don't know about them. Only one name came out during that. It is 569 to 479 BC. That time. Okay. Okay. So let us. BC is before Christ. Before Christ era. Before Christ it is. Okay. Okay, children, so we will begin with our exercise 6.5. First question, there are 4 questions. We have to check whether measurements of some triangles are given. We have to check whether these measurements belongs to a right triangle or not. Simple question. If it is a right triangle, how can we identify whether it is a right triangle or not? How can we identify, Anjali? Anjali, how we will identify a given triangle is a right triangle or not? If the measurements of sides are given, Anjali?
By using hypotenuse.
If sum of two sides equal to, sum of square of two sides equal to square of the third one, we can say it is a right triangle. Okay. So first question, right? First one. Determine which of them are right triangle. We have to check whether this measurements belongs to a right triangle or not. First one is 7 centimeter, 24 centimeter, and 25 centimeter. Always the longest, which is the longest side for a right triangle? Hypotenuse will be the longest triangle. So we will check whether this other 2 sides will come square of the hypotenuse. So first of all, find 7 square. 7 square is 49, isn't it? Then 24 square is what? 24 square is 24 square is 24 square
576.
576, yes, 576, and 25 square
625.
625. Now you just add 49 plus 576 and check whether you are getting, this is 625, isn't it? So we can write 7 square plus 24 square equal to 25 square. Therefore, the given triangle is a triangle is a right triangle. Right triangle. Given triangle is a right triangle. Therefore, length of hypotenuse is, what is the length of hypotenuse? Here 7 centimeter, 24 centimeter, 25 centimeter. Which is the hypotenuse?
25 centimeter.
Five.
The length which has longer side 25 centimeter is the length of the hypotenuse. Length of the hypotenuse is 25 centimeter. Same way you can check the second one. Second measurements are second one measurements are 386 3 centimeter 8 centimeter 6 centimeter. Check whether 3 square plus 6 square equal to 8 square. Are you getting? Check it. Find 3 square, 6 square, 8 square. Is 8 square equal to 3 square plus 9 square? Check. Hmm? 3 square is 9, 6 square is 36, 36 plus 9 is 45. Okay, not equal to 8 square. So 3 square plus 6 square not equal to 8 square. So the given measurements are not a right triangle's measurement. So given triangle is not a right triangle. Therefore the given triangle is not a right triangle. Not a right triangle. Okay, children, do third and fourth. Do it. Third one and fourth one. Check whether the given triangles are right triangle or not. Third and fourth. Try. Raya, did you check third one? Is it a right triangle?
No.
No, because 50 square is 2500, 80 square is 6400, 100 square is 10,000. But 50 square plus 80 square is not equal to 100 square. It is not a right triangle. Okay. Children need to do that on the board. Navneet, did you get? Third is not a right triangle. Did you get?
I am doing.
Do it. If anybody want, I will do on the board. Third one is 50 square. 50 square is 2500. 80 square is 6400. 100 square is 10,000. But 2500 plus 6400 is 8,900 only. It is not equal to 10,000. So we can write 50 square plus 80 square not equal to 100 square, not equal to 100 square. Therefore, the given triangle is not right angle. Is not a right triangle. Lena, do you get? Lena?
Yes, ma'am.
Okay. What about fourth one? Gautam, did you check fourth one?
Yes, ma'am.
Is it a right triangle?
Yes, ma'am.
Yes, good. It is a right triangle because 13 square is 169, 12 square is 144, 5 square is 25. By adding, you will get 5 square plus 12 square. It is a right triangle. And hypotenuse, Gautam? In the
Ma'am,
fourth,
159.
hypotenuse length
13.
13 centimeter. Length of the hypotenuse is 13 centimeter. Question number 2. All of you write question number 2. PQR is a triangle, right angle at P. M is a point on QR such that PM perpendicular to QR. Show that PM square equal to QM into MR. It's a good question, not it? We have PQR, right angle at P, triangle PQR, like our Pythagoras figure, triangle PQR, right angle at P. M is a point on QR such that PM perpendicular to QR. PM. M is a point on QR such that PM perpendicular to QR. This is the same figure like our Pythagoras theorem. We proved Pythagoras theorem using this type of a triangle. Since it is a right triangle at Q and PM perpendicular to QR, we can say what? Gauri? We have 3 right triangles here. So, using this we can say something. What can we say? Gauri?
90 degree.
A 90 degree. It is given. P is 90 degree and here at M also 90 degree. So, these 3 triangles, any speciality for these 3 triangles?
Angle M is common.
Angle M is common. Then Anything else? Can you say anything else about it? Karthik, can you say anything about it?
Are they similar?
Hmm?
Are they similar?
What? Louder.
Are they similar?
Yes, yes, they are similar. Why you are hesitating to say that? Our theorem says, if in any right triangle, if we draw a perpendicular from the right angle to the hypotenuse, it is divided into two right triangles. They are similar to each other and similar to the whole triangle. Gauri, just proved that the last period we discussed the same theorem. Clear, Gauri?
Yes, ma'am.
Okay, so here we can say that triangle QMP is similar to triangle PQR, and two side we can draw triangle QMP similar to triangle PQR, and triangle, I told you, in this type of question you start from QMP, then PMR. PMR similar to triangle PQR. Triangle PQR. Okay. Also we have these two triangles also similar. They are also similar. So we can write triangle QMP similar to triangle PMR. Those two small triangles are similar and they are similar to the whole also. Okay. The reason is the theorem you can write. If in some problem, if it is a 2-mark question, no need to write the theorem. Okay. Usually it will come as a 2-mark question. So no need to write the theorem. The theorem you know, that's theorem 6.7, the same theorem. Okay. So QM, we have to prove what? To prove as PM square equal to QM into MR. So QM by PM equal to MP by MR. QM by PM equal to MP by MR. So QM, look at the question. If you want to QM by PM we will, not MP. No. So we will PM. This MP we will write PM. Both are same, no. MR. Now cross multiply. Cross multiplying PM into PM equal to QM into MR. So PM square equal to QM into MR. PM square equal to QM into MR. We are applying that theorem 6.7. If a perpendicular is drawn from the right angle of a right triangle, it will divide into two small right triangles. Then these small right triangles are similar and they are similar to the whole also. Okay. Now question number 4. Right, question number 4. 3 is homework. Try 3 as homework question. Write question number 4. Question number 4. ABC is an isosceles triangle, right angled at C. both isosceles and right angle. Prove that AB square equal to 2AC square. ABC is an isosceles triangle. Right angle at C. So C. No, right angle at C. No. So this is BC. It is an isosceles. So AC equal to CB. Given that ABC is an isosceles triangle. To prove TP means to prove. To prove is AB square equal to 2AC square. It is a right triangle. So apply Pythagoras theorem. Given that angle C is 90, so you can apply Pythagoras theorem.
And that if that second question that repeatedly came, that another type, then we have to write that theorem.
No, because it is a 2-mark question. Then no need to write the theorem. By Pythagoras theorem, we can write AB square equal to AC square plus CB square. AC square plus CB square. But question is AC, no. But we can write AC square plus AC square. Why? Instead of CB square, I wrote AC square. Why? Why?
Four sides are equal.
Because
So,
AB equal to AC, CB equal to AC. Sides it is an isosceles triangle. No? Since it is an isosceles triangle, we can write CB equal to AC.
And sub question that which a third question sub question. Ma'am tell homework no that after that.
Third one. Question number 3.
So fourth one you are doing.
Yes.
Okay.
Okay. So AB square equal to 2AC square. AB square equal to 2AC square. Question number 5 is from deleted portion, so you can cross that. It's not there for using converse of Pythagoras theorem. It is from deleted portion. Anyway, it is very simple question, but
Can I repeat once more?
which one?
This is that first step. TP and TP what?
To prove.
Ah.
That is the question. AB square equal to 2AC square. Then we just applied Pythagoras theorem. Using Pythagoras theorem, AB square equal to AC square plus BC square, but AC and CB are same. So instead of CB, I substituted AC square. So AB square equal to AC square. Question number 6. Right. Question number 6. Fifth one, we are not doing the fifth one because it is from deleted portion. ABC is an equilateral triangle. ABC is an equilateral triangle with sides 2A. Okay. So draw an equilateral triangle with sides 2A. This is 2A. Here it is 2A. Here also it is 2A. ABC. ABC. Find each of its altitude. Altitude means what? What is an altitude?
Height.
Yes,
Ma'am, height.
perpendicular from an opposite vertex. It is a perpendicular from an opposite vertex.
Opposite vertex.
So D, AD is an altitude. First we will question find all the altitudes. First we will find AD. Then from B and C we can write similarly, same answer because it is an equilateral triangle. Okay. So now we will prove these two triangles ADB and ADC are similar. Try to prove similar or congruent. Any sides are, can we prove the similarity in this ADB and ADC? Try. Either similarity or congruent. Yes.
Ma'am, angle ADC and angle ADB are equal. Then
90
angle
degree.
C and angle B are equal.
Uh-uh.
Ma'am, 90 degree that.
90 degree, that we can. Angle ADB equal to angle ADC 90 degree. Okay, one condition. And C are equal, 60 degree. Okay, B and C are angle B equal to angle C. Reason 60 degree, equilateral triangle. Triangle.
AB is equal to AC.
Yes, equal. All angles are equal. So, AB equal to AC. By AA similarity, it is similar. Now it is similar because we need only two. Two angles, if two angles are equal, we can say they are similar. Along with, if AB equal to AC, since all sides are equal, can we prove the congruence? From the first two lines, they are similar. If two angles are equal, we can say they are similar. What about the congruence? Are they congruent? If AB equal to AC, can we say congruence? They are congruent by any of the...
Yes, ma'am.
Yes. How can we, using which criteria? Which congruence rule? Yes, it is RHS. Yes, because AB and AC are equal and they are hypotenuse of those two triangles. Are equal and hypotenuse. Hypotenuse of triangle ADB and triangle ADC. Therefore, by RHS congruence rule, triangle ADB congruent to triangle ADC by RHS congruence rule. Not only similar, they are congruent also. Okay, now what we need to prove? We have to find the length AD, isn't it? And BD equal to DC. How can we say BD equal to DC? What is the reason? ADB is congruent to ADC. Therefore, BD equal to DC. What is the reason? CPCT, yes, corresponding CPCT. Studied no last year. CPCT corresponding parts of congruent triangles. Corresponding parts of congruent triangles. See, by CPCT we can write BD equal to DC. The three sides are of length 2a. So how much this BD and DC? Sides are of length 2a. Equilateral triangle with the sides 2a. So
A.
S equal to, this is equal to BD equal to DC equal to half of BC. That is half of 2a A. BD and DC are A. Now look at your figure. We have these two sides are 2a and we got BD and these are A. Question, find AD. How we will find AD? How can we find AD? We got these two sides are half. From the beginning we can't say. Only by proving congruence we can say BD and DC are A. Because it is not a median, it is only an altitude. Altitude means it's a perpendicular from opposite vertex. So here we proved these two small triangles are congruent. So that BD and DC are A. Now how we will...
Pythagoras theorem.
Yes, Pythagoras theorem, because these two are right triangles. In any one of these two triangles, apply Pythagoras theorem, find AD. So, by Pythagoras theorem, we can write AC square equal to AD square plus DC square. AC is 2a. 2a the whole square equal to AD square plus A square. 4a square equal to AD square plus A square. Equal to 4a square minus A square equal to AD square. So 3a square equal to AD square. So AD equal to root of 3a square, that is root 3a. AD equal to root 3a. One of the altitude we got. AD equal to root 3a. Okay. Now in your figure you draw the other two altitudes also, that is BE. This is BE. Same way we can prove. So no need to prove, you can write similarly. CF, BE and CF. Draw BE and CF in your figure, then you can write similarly. Both are same. Similarly, BE equal to root 3a, CF also equal to root 3. Same way you can prove. No need to do it again. But mark the altitudes in the figure, then write similarly. B equal to root 3a, CF also equal to root 3a. Okay. Our time is up to 40 or 50. Yes. AB. So we can write AB square equal to OA square plus OB square. OA square plus OB square. In right triangle BOC, what can we say in BOC?
BC.
BC square, good. BC square equal to OB square plus OC square. In triangle COD, COD,
CD.
CD square.
CDC.
CD square equal to OC square, OC square plus OD square. And in triangle DOA, DOA,
DA square.
DA square.
Yes.
DA square equal to OD square plus OA square. OA square. Equation 1, equation 2, this is equation 3, equation 4. 1 plus 2 plus 3 plus 4 gives, add these four equations. 1 plus 2 plus 3 plus 4 gives, adding these four equations we get AB square plus BC square plus CD square plus DA square. This is left side. Right side is OA square plus OB square plus OB square plus OC square plus OC square plus OD square plus OD square plus OA square. 2 OA, 2 OB, 2 OC, 2 OD. So we will take 2 OA square plus 2 OB square plus 2 OC square plus 2 OD square. Okay, taking 2 outside, OA square plus OB square plus OC square plus OD square. And you just look at your figure. What about OA and OC? OA and OC are
Diagonal.
diagonals bisect each other. So what about the length OA and OC?
Parallel.
They are equal, bisect each other not. So they are
Equal.
equal. So we can write 2 into OA square plus OA square plus OB and OD are equal. So we will write OB square plus OB square. Write the reason in bracket. Write the reason in bracket as
One minute.
write the reason. What is the reason? OA equal to OC and OB equal to OD. This is the reason. So we have
Ma'am, I can only see the board. Ma'am, writing note I cannot see. No, okay. Now come. It was not there on the whiteboard.
So this is equal to 2 into 2 OA square plus 2 OB square that is equal to, we will write 4OA square plus 4OB square. Four OA square plus 4OB square. Again we can write this is 2OA the whole square plus 2OB the whole square. But 2OA is what? Look at the figure. 2OA is OA plus OA. That is OA plus OC is what? 2OA is what?
AC.
AC. Because OA and OC are equal. So we can write AC square, and 2OB is the other diagonal BD. Left side is what? AB square plus BC square plus CD square plus DA square. Question is very simple. You may feel it is simple, but while proving, if you are not studying, you can't get these steps in between. You will be confused. Only the Pythagoras theorem we are using here. We have 4 right triangles because the diagonals of a rhombus bisect each other at right angles. So the central angle is 90 for all those small triangles. So there are 4 right triangles. We are applying Pythagoras theorem. 1, 2, 3, 4. 4 equations. Then add the 4 equations. Then since OA and OC are equal, O is the midpoint of AC. Look at your figure. O is the midpoint of AC. So OA and OC are equal. So we are removing OC and OD also, because OD and OB are equal, because BD is the diagonal, O is the midpoint. OB and OD are equal. So instead of OD we are writing OB. So we got 2 OA square and 2 OB square. Now 4 OA square plus 4 OB square, 2 OA the whole square. 4 is 2 square. So 2 OA the whole square plus 2 OB the whole square. 2 OA means it is AC, 2 OB means it is BD. Is it clear, this one, children?
Yes, ma'am.
Okay, let me take your attendance. Alicia, are you present? Aaron?
Present, ma'am.
Alicia?
Yes,
God. Alicia present?
Yes, ma'am.
Alicia, for the first period what happened?
Ma'am, I was asleep.
Slept. Very good. No problem. If you want, we come. Otherwise, no. I am not repeating about the same.